Radios is an industry standard protocol that provides centralized authentication, authorization, and accounting for network access devices such as wireless access points and remote access server. Radios has been in use for many years, in particular by the Internet Service Provider. While the term radios is often used to represent the server hosting it, radios is a framework made up of a number of components, each with a specific purpose within the radios process. The following are the components of the radios. First, radios client is any device such as a remote access server, wireless access point, or VPN concentrators that accept remote connections from a remote access client. Note that a radios client is not a remote access client. Second, network access server, which is responsible for providing network access to a remote access client, such as a user needing VPN or DLN network access. Third, a radios proxy, which is a setting used to route radios messages between the access client and the appropriate radios server. Fourth, a radios server, which is used on networks to perform authentication, authorization, and accounting for radios clients or convey authentication requests to other centralized authenticating system, such as an Active Directory. And finally, the user account database, which is the database used by the radios server to authenticate users. This can be either a directory-based database or a local security account management database. Depending on your network setup, you may implement radios on different ways. Two common implementations of radios include environments with radios proxy servers and without radios proxy server. In the first environment, you use the proxy server for routing traffic. In the second environment, you don't use or require a radios proxy, and the traffic is routed directly by the radios server. Remember that radios server is the one that takes care of the AAA process, and the radios proxy is the one that routes radios messages between radios clients and radios servers. When used as a radios proxy, MPS is a central switch of routing point through which radios access and accounting message flow. Remote access connection requires authentication of the remote client by the remote server. To perform this, each party, client, and server must negotiate the use of common authentication protocol. While most protocols offer some level of security, some protocols are better than the others. There are three supported authentication protocols in Windows Server 2008: the EAPTLS, the PEAPTLS, and the PEAP MS Chat version 2. If you want to read more about these three protocols, go to page 355 of the book. In addition to the challenges of allowing remote access into your corporate network, recent advances in mobile computing technology have created a need to secure other types of network access. Whether the concern is securing wireless access point against unauthorized use or preventing visitors of consultants from plugging into an unsecured network switch in a conference room to attempt to access sensitive resources, there is a clear need to secure access to a corporate network even beyond the typical username and password authentication protections that were previously sufficient. To help secure network access for both wire and wireless connection, the IEEE developed the 8021X standard for network access control. This standard is port-based, which means that it can allow or deny access on the basis of physical port, such as someone plugging into a single wall jack using an Ethernet cable, or a logical port, such as one or more people connecting to a wireless access point using the Wi-Fi card in one or more laptops or handheld devices. This standard provides port-based security through the use of the following three components: supplicant, authenticator, and authentication server. The supplicant. This is the device that is seeking access to the network, such as a laptop attempting to access a wireless access point. The authenticator. This is the component that requests authentication credentials from supplicants, most commonly the port of a switch for a wired connection or a wireless access point. Despite its name, the authenticator does not actually verify the user or computer credential. Rather than the authenticator forwards the supplicant credential to the authentication server. And finally, the authentication server, as just mentioned, this is the server that verifies the supplicant's authentication credential and informs the authenticator whether to allow or disallow access to the 802.1x secure network port. The authentication server role in this kind of standard infrastructure can be performed by using the Windows Server 2008 computer that is running the network policy server role, as well as any third-party Radius server. When a wire or wireless port is secured through 802.1x, the following process takes place before network access is permitted. First, the authenticator detects an access attempt by a new supplicant. Second, the authenticator sets the port, whether physical or logical, to an unauthorized state so that only 802.1x traffic can be passed. Third, the authenticator sends an EAP request packet to the supplicant, requesting their EAP information. The supplicant responds with an EAP response to the authenticator, which the authenticator forwards to the authentication server. Fourth, if the authenticator server accepts this response, it instructs the authenticator to set the port to an authorized state so that the traffic can pass normally across the port. Authorized state. When the supplicant, when the supplicant is no longer using the secure port, it sends the EAP logoff message to the authenticator, which instructs the authenticator to place the port back into an unauthorized state. Well, student, that was all for lesson 9. Remember that if you have any questions or doubts or any comments that you want to add, you can use the discussion board for the lesson that you can find on D2L, or also you can ask any question during the class.